Okay, so today we want to do something called annuity. An annuity. Okay, an annuity is when you periodically into an interest-bearing account. Okay, that's called an annuity. So for example, if you pay every month $100 into the bank, and you do that for 5 years, that's called an annuity. Okay, you pay $100 every month into the bank, and that's called an annuity. Okay, everybody get that? That's a simple idea, right? But usually it's paying the same amount every month. So I said they pay $100 every month, and it should be an interest-bearing account. So it's an account where you get interest. Okay, everyone understand? So as an example, you pay, like I just said, pay $100 for every $100 per month for, let's say, 5 years. Okay, and let's suppose that you're getting, let's make it a crazy amount. You're never going to get this much, but let's suppose you get 12% per year. Get it, and you get 12% interest per year. Okay, so that's an example of an annuity. Okay, so if you put, how much do you pay into the account altogether? So you're doing it 12 times a year, that's $1,200. And then you're doing it for 5 years, so that's what? $6,000, right? So you're actually paying your own money of $6,000, right? So the question though is, what's the future value for this? Okay? So hopefully the future value will be greater than 6,000, right? Of course, right? If you're paying 6,000 in, it's going to be worth at least that. Right, but of course the thing is that you're getting interest, so it's going to be worth more than that. Okay, so the question is, how much interest do you get? That's what we want to figure out the future value, but what we really need is how much interest you're going to get, because then you're going to have 6,000 plus the interest. Okay, does everyone get it? So how do we figure this out? It seems like it's kind of not so straightforward to do this. So we can draw a picture of it. Okay, can I erase this definition of annuity? What is it? You pay periodically, usually every, the same period, so it's going to be every month, or every 6 months, or every year, or every day, or whatever. And usually it's the same amount. But I'm not sure if the definition means it has to be the same amount. But in our problems, it's always going to be the same amount. And it should be an interest-bearing account. Okay, so that's what we mean by annuity. Actually, I think some books call that an annuity, and actually our book calls that a sinking fund. So that makes some sense, because you're sinking the money into the account. Okay, so they call it a sinking fund. Okay, which I think they would say is a kind of an annuity. Like there are other kinds besides this. But okay, so let's not get too caught up in the words. So how much is it worth? How much is it worth? So we already said it better be worth more than 6,000. Right? But that doesn't tell us exactly. How can we figure out how much it's worth? Anybody have a suggestion? Well, it seems like it's a big headache, and it is a big headache. Let's see. Let's draw this timeline. Okay, and let's say, we're going to specify that you pay the money at the end of the month. So you don't pay it at the beginning. So it just makes the calculation slightly different. Pay at the end of the month. Okay, if you pay at the beginning, we have to do it slightly differently. So we're just going to specify that you're paying at the end of the month. Okay, so here's the 0. And here's the first month. Okay, so we're going to say we're going to put $100 in. Okay, and then you're going to put in, so this is how much you deposit, the amount that you deposit. So here, the second month, at the end of this is the end of the first month, end of the second month, you're going to make another 100. The end of the third month, you're going to make another 100, and so on. Okay? So after, let me change this to 2 years. Okay. So at the end of the last month, you're also going to put in $100. So the end of the last month is how many months?
60. 24.
At the end of the 24th month, right? Isn't that right? At the end of the 24th month, you're going to put in your last $100. Okay, so there. Okay, so that's a picture. Now how do we figure out how much this is worth? Okay, it looks hard, right? It looks like an awful calculation. Okay, maybe I won't make this so nice. Let's turn this back into not such a beautiful number. That number. Yeah, want that. Okay, so that's the interest you're getting per year. So it's only 3.6% per year. Okay, let's say we change it to that. Okay, so here's how we do it. I put this one in, and then I just treat that by itself. And I say, how much will that be worth at the end? So I'm going to put in this amount, and I want to know, what's the future value of this? Well, that you can do. This is a compound interest problem. Right? It's compound interest because you put this in, it becomes a little bigger after the first month because you get some interest, and then you get interest, and then you get interest the next month, and it keeps building. And it's a compound interest problem. Okay? But you know how to do that, hopefully. We did it last week. So what's the formula for compound interest? What's the formula for PV bracket? What? 1 plus I power of n, okay. That's certainly one way to write it. And what does n mean? The number of periods that you do it for, the number of so-called compounding periods, right? And what does I mean? So I is equal to this, right? No, it's wrong, right? That's not what I is equal to. R is equal to that, right? Right? I is the interest rate per period. R is the interest rate per year. Okay, you have to learn that, right? You just have to remember that. I is the interest rate per period. So I is not that. R is this. I is what? It's R over M, where M is the number of compounding periods per year. So how many what are we doing here? You can assume that, I didn't say it specifically, but in these problems you can assume that we're compounding it at the same rate that we're putting in money. That doesn't have to be true, but we're just assuming that. Okay, so the number of compounding periods per year is going to be 12. Okay, so I is equal to 0.036 divided by 12, which is what? 0.003. 36 divided by 12. Right, so that's okay, does everyone get that? Okay, so so how much is that worth then? How much is this $100 going to be worth at this point? So how many times do we compound it? Not 24. 24 minus 1. Right? From here to here is the first time we put it in here so it doesn't get compounded till here, right? So it's not 24, it's going to be, right? It's not 3, this is the second compounding period, right? So it's 3 minus 1 is 2. So 24 is going to be 23 compounding periods. So we get 100, 1 plus, we said 0.003 to the 23rd. Everyone agree with that? Is that okay? So this is, how much, so the question is, how much is that first $100 that we put in worth at the end? The answer is 100 times 1 plus 0.003 to the 24. Okay? Now we do it for the next one, $100. How much is that worth at the end? So the only difference is what? The number of compounding periods, right? Which is going to be what? 20, oh, I made a mistake, sorry. 23 here. And this is 1 plus 0.003 to the 22, right? Okay? And then the last one is going to be what? How much is this going to be worth? It's going to be worth 100. There's no compounding for that one. Right? I said we're putting it at the end of each period. So there's no compounding for the last one, right? So that's just 100. Okay? So then we can say how much is the whole thing worth? And of course it's just worth the sum of these individual payments. Right? So this is called, in finance, this is called something like, what do they call it? Like you want to compare, you always want to compare money at the same time. I forget the word that's called. But like, this $100 and this $100 in finance, they say they're kind of worth different because you got one earlier than the other. So it has, I forget the right word right now, but it's worth more in a sense, the first $100 than the last $100. Right? Because you can get the time value of the money. But there's some rule in finance about comparing money at the same point in time so that you don't have to deal with, this money came earlier, so it's worth more than it actually, that kind of thing. You try and compare money at the same time. Anyway, how much do we have at the end? We just have the sum of these things. Right? Okay. So we have to add this up, so let's write it down. So let's say we have 100 for this one, plus we have 100, next one is going to be what? 1 plus 0.003 to the first, right? Plus 100, 1 plus 0.003 to the second, plus, what's the last term? 100, what? 1 plus 0.00 to the 23rd. Okay? Everybody agree with that? Okay. So we have to add that up. Okay, that looks like trouble. But there's something called, there's a little math trick called geometric series. Geometric series. So let's suppose I write down, I want to sum up this. I think this is right. 1 plus, no, I think it's like this. A plus AR plus AR squared plus AR to the n minus 1 plus AR to the n. Suppose I want to add that kind of thing up. Well, that looks pretty much like this. Let's just confirm that they look kind of related. So we have something being raised to successive powers, right? We have, this could be AR0, right? In here. But anyway, we have R to the 1, R to the 2, R to the 3, R to the n minus 1, R to the n. Right? So we have something raised in there. We have something raised to successive powers, and that's what we have here. Something raised to the first power, something raised to the second power, and so on. Okay? So this is the R, right? In using that formula. Okay? And then we have something multiplying it, and it's the same thing multiplying it each time, and that works for this. This is the A. Right? So if we can figure out a formula for that, then we can figure out this. Right? Okay, so let's see if we can do this. So how about if I do this, if I do this, what's that equal to? R times Sn. So what do I get? I get AR here for this one. What do I get here? AR squared. What do I get? AR cubed. What do I get next? I think I did this wrong. Maybe it's okay. Okay, let's see. This is something's wrong. Anyway, I'll just keep going. ARN. Oh, I know what's wrong. I don't want this term. I only want that term. So if that's the last term here, then this is the last term there. Okay, now let's do, I forget which one I want to do. Okay, let's look it up. Let's look it up on Wikipedia. So look up geometric sum. Okay, so let's look up this thing here. Here. Okay, so they go to n minus 1 here. So this is what I wrote on the board, right? A plus A to the R plus A to the R squared, and so on up to the last one they're stopping at is to the n minus 1, right? Okay, then they do R times, so this is called S. See, here's S. Same thing. This is S. And then they do RS. So what do I get? I multiply I multiply this by r, so I get AR. I multiply this by r, I get AR squared. Multiply this by r, I get AR cubed. And multiply this by r, I get AR to the n, right? Okay, then they subtract s minus rs. Okay, this minus this. Okay, so this was clever. It's clever because you get all this cancellation. Right? If I do this minus this, do you see any things that will cancel? How about these two? Right? These two will cancel with each other, right? And these two will cancel. And these two will cancel. And there's something that will cancel with this, and there's something that will cancel with this. So almost everything is going to cancel. Right? What's going to be left over? This is not going to cancel with anything. Right? This is not going to cancel with anything. This is going to cancel with something in here, but this is not going to cancel. And those are the only two terms that are not going to cancel. So what are we going to end up with? If we do this minus this, we're going to get this minus this. Right? So we get S minus RS is equal to this minus this. Okay, so that's pretty clever, right? I call that fighting fire with fire.